Hello everyone. I hope all of you are doing great. Today I'm gonna show you another video on nitro reduction to amine. Um, Although you have may have seen my another video in my channel nitro to amine with activated zinc, but today I'm gonna show you nitro group reduction to amine group by iron powder. Now you may ask like why here I'm not using activated zinc, why iron powder. So there are some limitations for compound to compound. So if you have bromo group or bromide in your compound, so that would be problematic with the zinc. So here I am showing my the previous video YouTube link. You may give a look on that video also to know about the zinc activated zinc reduction of nitro group to amine. So as I was saying, like if you have the bromo group in your compound, so in presence of zinc, the bromine can be kicked out, or like it can give you the debrominated product. Nitro group may be converted to NH2, but your required bromo will be removed from the compound, which is not good. So that's why I am showing you a new reaction, um, which is be which will be done by iron reduction in presence of iron and acid in acid medium, and you require reflux, and solvent will be methanol. So here I'm gonna show you the reactions. Suppose you have a compound like which have bromine, nitro, and ester group. So this reaction is tolerant with the ester too. Ester will not break down, and especially the in presence of bromo. So if you use iron powder and HCl, 6 normal HCl in methanol, so you will get the NH2 like amine. So the conditions is iron powder in methanol and 6 normal HCl and reflux. Reflux means for the methanol it should be like 65 to 70 degrees Celsius. So 65 is enough, and it will be a 1 hour reflux. So here I'm showing also the reference paper. So it is Journal of American Chemical Society, or JACS 2013, and I'm showing the volume number 135, 46, and page number 174082, 17416, and they reported the yield is 92%, and I have done these reactions and I got 94%, almost close same. And this reaction is very nice, and it is not like troublesome like stannous chloride will give you the pain. So the reduction of the nitro compound with the iron is called Bechamp reduction, and Bechamp reduction is almost applicable to all aromatic nitro compounds, and aliphatic nitro compounds are like difficult to reduce, often remaining as the hydroxylamine. But if you have tertiary aliphatic carbon nitro group, it is easy to reduce to amine by Bechamp reduction. So let's see the mechanism how this reaction happen. So first nitro compound, it takes a proton with this O minus to form this intermediate, and then another proton and iron give 2 electrons to form this intermediate, and then by removing one molecule water it gives nitrosobenzene derivative, which will attach another proton to form this intermediate, positive intermediate, and again iron will give you 2 more electron to the nitrogen to form this n-phenyl hydroxylamine, and that will take another proton to form the positive ion and intermediate, and then iron will remove give the 2 electron to give you the aniline. here I have the nitro compound and iron. The reaction setup is very simple. I'm measuring the required amount of my nitro compound and the iron. So I'm gonna show like how to set up this reaction. So this reaction will be a small scale reaction, so I'm measuring very small quantity. um, Although I have done this reaction many times before, so now I need a small amount, so I'm showing a small scale reaction. So here I have taken my bromo compound. Now I'm gonna take the iron powder. So once both solids are measured, then I'll take these to my reaction flask. I will add in the reaction flask, and then here is my reaction flask. I'm adding both my compound and the iron powder. And this reaction flask don't need to be like completely dry, like flame dry, because ultimately you are going to use 6 normal ACl. That means ACl with the water. So just add methanol. Here I'm adding anhydrous methanol. You can use regular methanol, but that need to be pure. So using anhydrous methanol is safe, because at least it is pure. Like, it doesn't matter it has water or not, but it will be pure. Like, now I'm using the 6 normal ACl here. So here I'm showing the 6 normal ACl I prepared beforehand, before setting the reaction. So I'm taking around zero 0.5 ml of this 6 normal ACl, and my solvent is 1 milliliter methanol for like 30 milligram of the reaction setup. So you can scale up according to this value. So here everything is done. This reaction is like under nitrogen, since it is in reduction reaction. So I did degas, and then I start under nitrogen, and I closed the nitrogen, but I kept the nitrogen line on, so that the build-up pressure can go through the well. But now I'm fixing the temperature, so it should be 65 degrees Celsius. And so now everything is ready. I turn on the water. Make sure that you turn on water with the condenser. So the reaction setup is done. Now I'm waiting for like 65 degrees Celsius. Here you can see that the methanol is refluxing at 65 degrees Celsius. So after 1 hour I will just cool down the reaction, and then I will add sodium bicarbonate saturated solution, and then I will extract with that ethyl acetate. And that's it. That will be the reaction crude, and then um, you can either recrystallize or like purify through column chromatography. If you like my video, please subscribe my channel and watch my videos, and you can share those videos. Stay fine. Goodbye now.